three wheels can complete respectively 60, 36, 24 revolutions per minute. There is a red spot on each wheel that touches the ground at time 0. After how much time will this spot simultaneously touch the ground again? Okay, so there are three wheels, and let me tell you, the smaller the wheel, the greater the revolutions it makes. Okay, so first wheel, it can make 60 revolutions per minute. Second one, it makes 36 revolutions per minute, and third one makes 24 revolutions per minute. Okay, there is a red spot on each wheel that touches the ground at time 0. So this is the ground, and there is a red spot on each of the wheel that touches the ground at time 0. Okay, so first of all, it does 60 revolution per minute, so it can do 60 by 60 revolutions per second. Okay, so that means 1 revolution per second. So similarly here, 36 divided by 60, so it makes 6 6 are 6 1s are 2 3s are 2 5s are, so it makes 3 by 5 revolutions per second. And again we divide it by 60, so it makes 2 by 5 revolutions per second. And when we inverse this, we get 1 second per revolution, we get our time. Here when we reverse it, we get 5 by 3 seconds per revolution, and again here 5 by 2 second per revolution. So we have our time here. So first we'll take 1 second to complete 1 revolution, second one takes 5 by 3 second to complete 1 revolution, and third one takes 5 by 2 second to complete 1 revolution. Alright, this much is clear. Now the question is asking us how much time will this spot simultaneously touch the ground again. So for this, to calculate the common time, we have to calculate the LCM here. LCM of 1 by 1, 5 by 3 and 5 by 2. So first of all, I'll quickly calculate the LCM here, and after that I'll tell you the concept behind this, why we take the LCM to find out the common time, to find out at what time will they touch simultaneously. Okay, so first of all, let's see. In order to calculate the LCM of fractional values, we know that we have to first calculate the LCM of numerators, and then we have to divide it by HCF of denominators. Okay, this is how we can calculate the LCM of fractional values. So LCM of numerator, which is LCM of 1, 5 and 5, it will be 5 only, and highest common factor of denominators, that is 1, 3 and 2, so it will be highest will be 1 only. So 5 by 1, which is 5 seconds. So that means after 5 seconds all these spots simultaneously touch the ground. So this is our required answer. So here option C is the correct one. Now let's see why we find out the LCM to get our answer. Now talking about the first wheel here. Okay, for first wheel, we know that it touches the ground on first second. Okay, then after that, when will it again touch the ground? On another second. So on second, on third second, on fourth second, fifth second, and so on. Okay, for the second wheel, it touches the ground on 5 by 3 seconds. After that, it will take another 5 by 3 seconds to complete to touch again. So 5 by 3 plus 5 by 3, it will be 10 by 3. It will take again 5 by 3 seconds to complete the entire revolution. So 10 by 3 plus 5 by 3, so 15 by 3, and so on. 20 by 3, 25 by 3, and so on. Okay, for the third wheel, it touches the ground on 5 by 2 seconds. Then it again takes 5 by 2 seconds to complete the entire revolution. So 5 by 2 plus 5 by 2, it takes 10 by 2. Then again 5 by 2, so 15 by 2, so 20 by 2. So it will keep on going. Okay, now what is the least, when is the first time they will touch the ground? So here 5 is common, here 3 5s are 15, here also 5 is the first value, and here again 2 5s are, here again the 5 is the first value. So that means all these three wheels will touch the ground simultaneously with the interval of 5 seconds. Okay, so first they will touch on 5 seconds, then again they will touch on 10 seconds, then again they will touch on 15 seconds, and so on. Okay, so that is the reason why we have calculated the LCM, where we found out the least common multiple when they will touch the ground. So this is the concept behind finding out the LCM. So I hope you are clear about this. So your option C is the correct one.